Hmm. Oh, hey, Neko. How are you? I'm fine, I guess. Kinda hard to concentrate today again. I feel like I'm burning out. I'm not sure. How's the sound, by the way? Couldn't check for a long time now. Oh. Wait, when did your vacation start? Was it this week? I see, I see. And what are you doing in your vacation? You said you're staying at home? Playing VR chat all the time, I guess. I see. What did you see? Oh damn, that sounds awesome. I hope it's not raining. Well, sounds like a good plan. I mean... How am I going to do this? Well, if you're driving around, you're a tourist too. What are you talking about? Oh damn, 2 hours? Neko, maybe you can help me. I have this problem. So since I made this module to have a battle, I found out, okay, I as a player have multiple Orblings, but my opponent probably has also multiple Orblings. And then I was like, okay, when I'm on the overworld, maybe I want to see them as multiple and not a single Orbling. So I'm now doing some Orbling swarms. As in, they fly as a swarm, one lands, the other Orblings follow the materialized one. Now there's a problem though. If I have a Orbling swarm, indicated by this X, how do I distribute all the Orblings so it doesn't clutter up? My idea was give this thing random positions all around in 3D space. They're all attached to one thing in the middle, and then I rotate that randomly. These things are targets. and the Orblings try to follow these targets. And while trying to follow their each individual target, it will be like flowing around, and they will be squiggling around like this and whatever when they fly, you know? There's this direction and they will be like this and so on. Hey Tentur, wait, who is Tentur again? Welcome, welcome. I forgot. Ashima! Yokozo! So now the problem is, when I randomly add these things, like this is the middle point, and then I have one here, one here, one here. Since it is random, they can also be like here, 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 and then they will be cluttered up again. Now, I want this to be random, but also not too random. How do I do this? Let's see. We have a 2D plane, and there's the middle point. If I want a random position, I can just choose one, and then the next one should not be in this area, I guess. But I should not just go about and then... Hey, is this near one? If yes, choose another one. That's a stupid idea. Maybe I could draw a squiggly line around this point, like this, and then choose random places from there, but it will still have these cuts. I mean, in 3D space, it would be very, very hard to be... But essentially, I'm just doing the random thing. Maybe internet can help me here. How about this? No, generate random points distributed like cities. Affecting features and special point present. How are you doing, by the way, Shima? Generate random points. Flutter models. How are you? O genki desu ka? Your points randomly. With space evenly, that's good. I like that. Yeah, whatever. Yeah, something like this. Poison disk sampling. I'm also good. I'm also good. Check some article, la la la. I guess. But can I do this poison disk in 3D? Does Unreal know this already? Wait, how to write it again? Poison. Sadly, no. This is in Unity. Okay, so number of attempts before making samples. Oh, this guy is also using attempts. Okay. Okay, whatever. So cube. Radius, cell size, grid, whatever. Maybe it is. I'm trying to read into this algorithm. Probably is. I mean, let's see. Survey methodology. What is sampling? Statistics, so it is math, yes. So add sample, where is this? Active sample, add sample. Grid position, new grid position. What is this? Is this struct XYZ sample cell size? Grid X sample. Okay. So it just gives a vector. A sample is nothing else than a vector. It just saves itself. A vector and the cell size, which is... What's the cell size? Where is that? Copy. Just a float. I guess the cell size is a constant somewhere. Here, float. And it is set to what? Where do you set this? Here, radius. I see. Why do you cube this? Divided by cube of the square root? My mind is spinning now. It's getting complicated. Well, it is randomly trying. There are random points around the sample, and then accept candidates if it's inside the rect and farther than 2 radius to any existing sample. Hey, so stupid. That's my initial idea. That was my initial idea, which I thought it was stupid. And this has a name. Oh, god damn it, man. I just didn't want it to try multiple times and fail. I don't want that. Okay, I guess I'll come up with something of my own. Let's see. Square 1 again. So let's say we have a middle point. Can I do something like this? But how do I do a spiral in 3D? Or do I do something like this? This is a spiral here, and then there's a spiral here, and there's a spiral here, and then there's a smaller one here, and then it's like a ball. And then it can randomly pick something on the lines. I don't know. Maybe the stupid solution is the best solution, which is just randomly put in there, and if it's too close to another one, then just try again. Okay. I can do this. This is no problem, but let's say if I have 10 points to put around, this is way too much. I guess what I have to do here is... Oh god, do I need to implement a chain? Like, okay. I have points here, 1, 2, 3, 4. And after that, the next points needs to be chained to the others. Or something. That's also stupid, because then, if I have one here and one here, the chain from this guy can be very close to this one. Oh my god, I'm losing my mind! What if... I think I have the solution. Let's say you are in this 3D space. This is the center of our swarm. Now I have a count of Orplings. Let's say 100. This is an extremely high number. It should normally be around 5 max, maybe, and in special cases even 10 or something, but most of the time only 3 or 5 or something like this. When I initialize this thing now, I slice in 3D 2D plane this part and put a random position here. Then I go a gap here. This is a gap. Let's say gap is 5 units. And then I slice it again. Like this. And then I find a random point there. And do this all over. And then I should get something like a worm. Then my end result would be, here is this guy, and then here is one slot, here is one slot, here is one slot, here is one slot, and so on. Of course they could be like this, but that would be fine. Now, this of course would be like just a line. We would never have this interesting thing where things could be like this. But that does not matter, because all these points should have a radius here, and then they will spin like this in random speeds, maybe even. I think that's good. And maybe in other directions too, and then they will be like, if this flies, then it will do these things and whatever, and I think that's good. What do I need for this? I don't need much. I just need a spinning value. A spinning speed. But now I have another problem. If we have this, let's say, swarm of a bus, like this, and we have all these slices, and the Orplings will follow these slices, and then there's a point which rotates. Firstly, I would have to update n, which is the size of this, in tick. This is not good. This is too heavy. Because I don't have just one swarm, I have multiple swarms. What if I make updates 1 to 4 maybe instead of n? n is the count size. Then I could say 1 is a different speed, 2 is a different speed, 3 and 4. And then it would be different enough. But the second problem is, this bus, it is not a worm, it is a very hard thing. If this thing wants to turn now, this whole thing goes to the other side. So I need to make a worm. How do I do this as a worm? Is there an easy way to make a rope? There's a cable component, but I guess that's not what I want. Or maybe it is. Fix particles, but this is a particle. I don't want a particle. These are all effects. Gain component. Oh. Nope. It's a plugin. Okay. Just a second, be right back. Alright. So solving this would require to have a sort of chain thing. And like this. Having a worm of a swarm. Tadaima. I could also like have a cube very mess cube, but you guys get the idea, I guess. And then have inside small cubes. Like this. And only in these cubes I can spawn. And if one cube has a spawned one, then the neighboring cubes are a no-go. And then I just get the cube and rotate all over randomly or something. Which would again mean that if I have too much Orblings, it will be cluttered. This would solve the cluttering, but would make a very bad thing with the chains. I don't want to have such a demanding thing and complicated thing to implement. I guess I'll go with this one. And is there not a simpler solution to this? I guess one simple solution would be never have too many Orblings, but that's not an option. Does this effect look good? I don't know. What if I mix it the two? Wait, maybe I don't rotate the cube. Maybe I just spawn the things here and then they all have this axis to rotate. Or the other way around. Uh, what if I just don't give a shit? I don't care. I have a swarm and I do random positions, and if they are too too next to each other, I don't care. And all I do then is I have 4 speeds, which I tell them to randomly turn on an axis. Then it does not matter if they are close because they are turning anyway. Then all I have to do is have 4 different scene components all in the middle, and they all rotate in different speeds while these guys attach themselves to them. Monkey, you are a genius. So this 天才すぎる。天才すぎる? How to say? 天才? 天才すぎる。うん。そうそうそう。Yeah, I guess so, but I'm already modifying so many things. It's very, very confusing. Now, we have a random float here, which we multiply by a maximum speed. Let's say, I don't know. For now, 10. And then we add this here. No, actually, we don't add this. How do I do this? Random bool? And then we do this. And then we do this. And if this is true, then we do this. And Actually, this is so stupid again. Why do I do 2 randoms if I just can multiply it to a thing? So we have a float. Let's do minus 0.5 minus 0.5. So it is the half of the maximum of this, because this is 0 to 1, and I do this, then I could also, wait, multiply by 2 and then minus 1. So I have half of it, like this, multiplied by 2, minus 1, I have half of it. And then this is already, now it can be minus 1 to 1. And then I can just add it here. So we have a rotation that can go clockwise or counterclockwise, depending on the random float. The wonders of infinity. Now we take this and say we do this 4 times. Is the last index the last one that goes in or not? Let's try this out with our test map. Actually, does it say? It does not say, of course not. But system, opting swarm, yes please. And then we go here. And then say for loop. Give me the loop. Loop, loop, loop. And say for, and then we say print this thing at begin. Now I would say this will now print 0 to 4, which is 5 numbers. And it is 5 numbers, so we have to go minus 1. Thank you. Bye bye. So we want 4 numbers. So we do this. Now we have 0 to 3 numbers. And having that, we can now go here. Need to understand what's forward, I guess. Do we use X as forward? How did I do it with the Orpling? Show me. Do you have a visual part? Okay, and you are using X. Okay. Let's keep being consistent here. This is fine. This is fine. Okay, so we have these, and then how do I rotate them? That relative rotation, world rotation. Can I not rotate as a function? Add rotation. I should do this dynamically. Like this. Okay. Number of roots will now be the thing that will tell us how many rotators and how many rotator slots we have. Minus 1. Add this here. Let's say that this guy is 4. Nice. Now we can tell this guy that this guy, for each add rotation I guess it's a relative rotation. Would make sense. But we will see if it's breaking that. And we are rotating from the x-axis. So we get this on this index. Do this. Multiply this by delta seconds and the maximum rotation speed, like this. Put this on X, put this here, and voila, we have our rotators. Now this has to be on the event tick, of course, which we will connect now. Initialize swarm cluster, blah 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 blah. The airplanes are here, but they need positions. This guy needs to go and position them. This needs to happen before. Let's make a function for this. This. Where the hell? Okay, yeah. Should happen here. Then, for each of these guys, I need a iterator. Local rotator iterator. And we need these. Okay, so this guy is spawned. Gets one off from the list. Initializes it. Spawn Theos constant. It's a float, I guess, in a radius of 100 cube radius, that is. Random vector. Multiplied by this guy. Then set relative location. Actually, let's attach this first and then set its location. Get from this index. And then attach component to component. No, wait. Is this an actor? Of course, yeah. Wait. Oh. Cannot attach the Orpling itself. Oh, it's getting complicated again. Needs to be this guy. Wait, did I? I didn't even create them yet. I need still to create them. Which we can do, of course. We can say add component scene. Let's this thing. And then this guy needs to be here. This guy needs to be this. So the Orbling gets initialized. Then actually I guess we need this in components. And then on initialize, we add in components swarm follow slots. This guy needs to be set like this. All right. Now, in the future, I can use this to follow. This is good. I guess what we will have to do now is we have to create the scene component first and add this here. Voila. Now we can attach add scene component. This needs to be attached to this guy. Attach in component. Okay, wait. Attach component to components. No, not default. I want the rotator to be the parent and the created slot to be the target. Heap relative is correct. And this goes in here. Ta-da! Okay. So what are we doing? We have an Orbling list, so we go to for each loop, create a slot for each of them, add them to the swarm slots. However I'm doing this, I guess I don't need this, but whatever. Then get the first rotator attach the scene component to the rotator and then initialize the Orpling. And then we have to iterate. Of roots. +1. If this is smaller than the number of roots, then indeed you have to add. But if not, if it is the number of that, then we have to say it's 0 again. All right. I'm not using that, am I? Okay, so essentially we now created this thing where we add a target scene component, then attached it to one of the rotators, which always iterates to the next one, and then we initialize the Orpling with its target slot, so I can tell him to follow it afterwards. Now we can see if actually the rotators do spawn. All we need to do is check it's 4, so what we assume is to find 4. Do we have a swarm? There's a cluster. I don't see a swarm. Oh, there's the swarm. Perfect, then we go here. Get this guy. And say, hey, initialize. And I don't care about all these things, I just want to see what happens if I press play. Uh-oh. What happened? Why did this not go through? But it does create it. What's going on here? Damn. What I can do is swarm rotators. No get. Swarm rotators get. And then we print. Like this, and then say print hello. Oh. Play. Or, so it is there, but it does not show here. Why ever? The scene components are there, but I cannot see them here. Interesting. That's sad because I would like to show them, make them visible. And I don't want to go with debug stuff. I just wanted to press on them and then see, there they are. Interesting. Do I need to do something? Maybe I have to do something. Add scene component. Attach to component. And then say it's the root. Maybe that's the problem. And keep relative is correct. And then say compile. And then I press play. Form. No. Interesting, I'm not expecting this. Oh, this is bullshit. I don't like this at all. Oh man, that makes me sad. Damn it. This is stupid. What the hell? I guess they need to be here to be shown. Hey Death, welcome to the stream. I guess I cannot just change the category here. Well, I mean, I don't need to see them. I don't need to see them. All I need is some indication that they really are there. Let's see how this goes. So yes, there is a rotation here. Although I don't see the component, the component itself is there. So no need to worry, I guess, for each. Yeah. Three of them go minus in different speeds. Although they look very, very similar, but they are not. And one goes positive. And now they are positive, 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 negative. Is this random? Really doesn't look like random. There's always three of the same kind. And now it's different when I added this thing. Minus, minus, plus, minus. Plus, 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 minus. Minus, plus, plus, plus. Plus, plus, minus, minus. Okay. That's good. So we have the rotators. We have the random positions, which I could also go ahead and test. But I need to reconnect this and add some ARPlings. Also, this guy can be deleted. So for each get location, word location, print, and I would now assume that there are some varying values if I of course add some ARPlings here. Add ARPling, add ARPling, add ARPling. Save. Boom. And indeed, they seem to be turning. Maybe I could also change the maximum speed here to 100. Yeah, this one looks like it's making a sinus, like goes to 733 and then 926, and then it just wobbles around. Should be the same thing with the z-axis, which is exactly what I want because this is a circle and the x stays Does it make sense? X is turning, so of course it should stay what it is. These values are kinda nearish. They seem to be very close together. What a coincidence. God damn it. Maybe I should care about this. They're so freaking close. They're not always close, but I guess I will leave it at that until I have some visuals for this. Okay, with this the initialization should be done. And now the fun part begins, where I implement all these commands. But I guess I will do that next time. Let's get some order in here. Oh my god, I can't just get a random item? This is awesome. And it tells me which one. So all I have to do is execute command. No. Execute command. And then tell them to follow. Maybe follow slots or something. And this guy. Execute those lands. No. Actually, no. This would be this guy. For the first one, this is fine. We need to implement movement functions. Alright, that's it for today though. So guys, thanks for tuning in. Thanks for the support. And I will see you guys next time. Bye bye. Good night.